Hello, everyone, and welcome to today's webinar, Istio, Enabling a Defense in-Depth Network Security Posture. We're glad you all could make it. It's a hot topic. There are a lot of you here, so we hope that you enjoy this presentation and get a lot out of it. First off, I would like to introduce today's speaker, and that is Christopher LILJENSTOLPE. He is the original architect behind Tigera's project Calico, probably the de facto network security solution for Kubernetes. He speaks at over 60 meetups yearly, speaks to conferences, educating people on networking and network security for modern microservice-based container applications. He also consults Tigera's enterprise clients on security and compliance for their applications. But before I hand over the webinar to Christopher, I have a few housekeeping items I'd like to cover about this presentation and the webinar platform in general. First off, today's webinar will be available on demand immediately after this session. You can use the same link that you access this webinar to watch it again if you'd like. We've also added some attachments and links to the section where you will see attachments and links. There you can find, we have a Kubernetes implementing network security guide. We have a top 5 best practices in network security and Kubernetes, and we also have a link to our enterprise product. So upcoming also, keep in mind we're going to be having a white paper on Istio, and so that is due out this week, and it's a great paper so far. We're just putting the finishing touches on it, and we will email this white paper to you so you can have that. And next, and finally, we'd like to hear from you today during the presentation. So if you have any questions to ask about the topic, especially while he's talking about a certain subject, feel free to ask those questions by going to the questions tab in the interface, and we will try to answer those questions as they come so that we can keep them pertinent to the topic. But if we don't get to your question, we will have a full Q&A session at the end of the webinar. We'll take all questions and answer them. And a copy of the presentation will be made available to you after we're done. So without further ado, let me hand it over to Christopher. Christopher?
All right. Thanks a lot, Michael. So welcome, everyone. And as you heard, we're going to be talking mainly about what we call application layer policy here at Tigera. And it's some work we've done with the Istio community to bring network policy up and beyond just layer 3 and layer 4. And let me spend a little bit of time on that before we go into some of the details. So if you start thinking about network policy, and we've talked a lot about network policy and security here on previous webinars, most of what we've talked about to date has been around layer 3 and layer 4. And that's been, things labeled Bob can talk to things labeled Alice on port 443. And that works. And there's lots of things that still rely on classical networking. Opening applications will open up ports and make connections using, using standard networking concepps. And there's some benefits to the way that we at Tigera enforce those policies by enforcing those outside of the pod, for example. We talked about this before, enforcement multiple points, such that even if a pod, for example, in Kubernetes becomes compromised, it can evade the network policy controls, i.e. those L3, L4 policies. However, as more and more applications move into what I'll call more WebSockety models, more higher level abstractions, where you're not necessarily making a call to a IP address and a port, but instead you're making a call to a service identified by a URL. Those things, as more and more of those applications, that application level networking becomes predominant, you need to do things other than just L3, L4 network policy. And that's because, frankly, at the end of the day, if everything in your application estate, for example, is using WebSockets, REST type calls, or gRPC calls, pretty much all you have is 443 traffic running around, and most of that's going to be encrypted, right? So your network controls for these more modern applications start becoming fairly constrained by the fact that the differentiation about what you are trying to connect to is really being defined at a higher level, that application layer, rather than at layer 3, layer 4. So to date, what we've done in enterprises is we've done things like WAFs, web application firewalls, etc., where you have a separate set of infrastructure and a separate set of policies that define web tier firewalling, what URLs you're allowed to access, what kind of verbs and HTTP posts gets, etc. you're allowed to do. And that's separate from the network firewall infrastructure, i.e. this host can talk to this host on port 443. I'm sure for anyone here who has run these disparate environments, the WAF and the network firewall, you will have run into cases where, for example, the WAF rules don't quite match up with the network policy rules, and you have interesting failure modes where, for example, one policy allows traffic and another policy denies traffic. So, and similarly, again, we have the same problem. How do you identify what this thing is? You know, what things should be allowed to make an HTTP get to a given URL service? Because applications are constantly changing. So we basically at Tigera decided that it made sense to take the network policy model that we had basically pioneered, and that's now a key part of Kubernetes network policy strategy, and extended that to layer 5 through 7. And we call this application policy. The next part of this, though, is once we decide to do that, we have to pick what is the right tool to enforce these policies. And about the same time we were thinking about this, the Istio project was kicking off. So we became early contributors to the Istio project. We've been very active in that community. Istio's security working group co-chair is a senior engineer here at Tigera. And we basically have taken the concept that a network policy should be able to refer to things all the way up the stack from L3 to L7, rather than saying having separate policies for L5 through 7, and separate policies through L3, L4. So we're going to talk a little bit about that and how we do that within the context of an Istio environment. If anyone wants to have a further conversation about why Istio, independent of network security policies, we're going to be discussing that over time, and we've got some training and other things, but we can also have an Istio overview at some point. If folks are interested, please just let us know. But we're going to really focus now on using Istio as a network policy control enforcement point, rather than all of the other goodness that Istio brings, like visibility and load balancing and circuit breaking, et cetera, which are all great and wonderful things and reasons you should deploy Istio independent of what we're going to be talking about here, which is network policy. So you sort of get a 2 for, or actually about a 5 for, if you deploy Istio. You get a whole bunch of application layer semantics that make developing WebSockety, REST, gRPC-based applications much easier and more rugged and resilient, and you get the ability to have a common network policy model all the way up the stack from L3 to L7. So before we talk about Istio particularly, let's go on and do a quick reminder of what is an L3, L4 network policy in Kubernetes. And this is what you see here is a network policy. Oops, let me turn off my phone. And since this is live, you will get that little Chris forgot to put do not disturb on his phone. For those of you who know my phone number, you can check to see if I forget to do that again by doing that at the sending me a text at the next webinar and see if I repeat the same mistake. Anyway, so this is an Kubernetes L3, L4 network policy. This is a really simple one. This is basically saying things that are PCI compliant should be able to talk to things that are PCI compliant, and we shouldn't be allowing traffic from non-PCI compliant workloads to talk to PCI compliant workloads. So the first thing that sets this up, this is a Project Calico API global network policy. We name it, and we give it a PCI, we give it a name of PCI isolation, and we optionally confine it to a given namespace. But then the key thing here is we say that this policy that we're about to get into, the ingress and egress section, the action section, if you want to think of it, of the policy, will be applied to any workload where there is a label that says PCI, a label where the key PCI is valued true. So basically, the two workloads, the red ones here, will have this policy applied to them because they're labeled PCI. The policy statements basically say that for any ingress traffic, we will allow traffic from things that are labeled PCI. And same thing for egress. We will only be allowed to send traffic to other workloads that have a label of PCI. Now, we haven't said what ports, et cetera, that can all be scoped. So basically, if a PCI node tries to talk to another PCI node, it will be allowed in this case. And if not, unless there's another policy that would allow said traffic, the global default deny that Tigera implies by default would block that traffic. So this is an L3, L4 policy. And this is, for many things, in fact, most workloads today, especially in enterprises, this is the layer of at the network where most applications reside. So this is all your heritage applications, even fairly modern applications. And even, I would say, if this application is a WebSocket or a REST or gRPC application, primarily because of where we enforce this policy. So let's talk about that on the next slide. And if we take to think how this is implemented within a given node in Calico or in Tigera's solution, we have on each node an agent called Felix, and that listens to a Calico policy repository that's stored in Kubernetes key value store or in etcd directly. And if there is something that exists on that node, Felix that attracts a specific policy, in this case, say a PCI is true labeled workload, then Felix will write on that node into the kernel network filtering infrastructure a policy that will allow traffic from other PCI labeled true workloads, or either traffic coming in from or traffic going out to. And if there's other rules, then everything else is blocked. This is happening at the underlying kernel layer in the node. So even if a pod becomes compromised, it will still be filtered because the pod, by definition, doesn't have access to the root namespace on a given node in Kubernetes or in any containerized environment. So basically, this is an enforcement point outside of the scope of the node, and it operates at layer 3, layer 4. But let's say now that we've moved to primarily an estate or a cluster of applications that are gRPC or HTTP centric in their API calls. So as we said before, if we take that to its logical conclusion and say every single application inter-process communication between different pods or different microservices is going to be done at the gRPC or HTTP layer, the policy statements are going to be fairly straightforward at L3, L4. It's going to basically say, I'm allowed to talk to anything on 443. That doesn't really provide much in the way of security. So let's talk about some extensions that we have done. These are available in both the open source product and now GA. It's been in demonstration for almost a year now, but it's now available for GA in both Calico and our commercial product, Tigera Secure Enterprise Edition. Let's talk about what we can do. So this is going to be an example called book info sample application. And the idea here is a request comes into an ingress, which we're not really going to talk about here. And then it's going to come into the first or the front end of this application. And it's going to, and that's going to be this product page web front end. And that's basically going to list all of the products we have in our bookstore. And then what we're going to do is have a couple of different customer backends where customers can get reviews of the book that they're interested in buying. And the first version we released only lists like written reviews by other users, but doesn't have star ratings. And then at some point later, we deployed a star rating system. And we basically, in the version 2 of this, the stars were black. And their back-end data store was from a Node.js application that's running a ratings code that basically calculates the average star rating for a given book. And then later we did version 3 because A/B user testing said that red stars might be better. So we wanted to try both black stars and red stars. Both of them, again, pulling from a Node.js node. And then finally, if you want to get details about the book, how many pages, who the publisher, the ISBN, et cetera, all that data comes from a details Ruby script that's running in another pod. And all of these are going to be controlled by these black bars in each pod, which are the Istio proxy, which happens to be Envoy. In almost all Istio deployments today, if not all Istio deployments today, Envoy is a proxy. It came out of Lyft, and it's a lightweight HTTP gRPC HTTPS HTTP2 proxy. So in all of these cases, these are installed as sidecars in a pod, which means it's another container in the pod, but it's within the same pod's namespace. There's some advantages to this. First of all, it means that all traffic in and out of a given pod, even though it's going through a proxy, still is coming from that pod, not from a shared proxy IP address. So we still have full visibility, like Kubernetes originally intended, about which pods are talking to which pods. Also, since Istio is mainly handling now the MTLS and encryption and certificate checking for all of these HTTPS connections, it is doing so within the pod, which means that the cryptographic material, the keys, etc., are contained within a pod. We don't have a shared proxy where all of the applications or instances of an application that are behind the shared proxy have to share with that shared proxy their cryptographic material, and therefore a compromise of that shared proxy compromises a lot of workloads. In this case, a compromise of a key within from a proxy is only going to impact the thing that proxy is directly strapped to, the single instance. So a compromise has a much lower blast radius. It constrains the security perimeter and the cryptographic material within the security perimeter of a pod. So we now have, again, this idea of a pod is a entirely self-contained thing, Kubernetes, and it doesn't necessarily need to rely on some shared resource. So in that regard, the Istio architecture is pretty well aligned with Kubernetes, which makes sense because it came out of Google and IBM. But this is the application. Now let's talk about how we can extend Kubernetes network policy to protect these. This becomes specifically interesting because all of these are 443. So basically, in a network policy standpoint, we basically say that product page, things labeled product page, can communicate on 443 to anything labeled reviews or details. Then similarly, reviews and details will allow traffic in from anything labeled product page. And things labeled reviews v2 or reviews v3 can send 443 traffic to ratings, and similarly, ratings will allow traffic from things labeled reviews v2 or reviews v3. So that's sort of coarse-grained. So let's try and make this a little more specific. Last thing I want to cover here, as we say, is that if you turn on service mesh MTLS support in Istio, it's a global setting, then if we've attached service accounts to these things, reviews v1, reviews v2, reviews v3, etc., product page, then by simply turning on, attaching service accounts to these endpoints, Istio will automatically do mutual TLS authentication, or enable mutual TLS certificates anyway, and we'll talk about how we then drive the authentication. So let's talk now about a policy, going to the next slide. So this looks very similar to the network policy I showed before, and these two things can be mixed. But now we basically say that app details, the API version, by the way, is incorrect. I grabbed an old version of the slide. I apologize. This would say global network policy, and Project Calico v3 would be the same preface as we saw in the earlier network policy. Anyway, this is basically saying that any application and anything labeled app details will allow traffic in, but now instead of from a pod labeled product page, it's going to allow traffic in from anything that has a service account attached to it with a name product page. Since we're using service accounts, if we turned on MTLS in Istio, this means that this isn't just going to be allowing traffic from things labeled with service accounts, which is another type of annotation, product page. It will only allow the traffic, the details, the Istio proxies in the details and instances of the details apps will only allow traffic from things that have a TLS certificate that has been assigned to the service accounts with the name product page. So we basically now enforce an MTLS authentication of this traffic. So now it's just not the IP address, it's actually an MTLS certificate that's being used to grant or deny traffic here. Similarly, if I have an applications ratings, if you remember, that was the Node.js, I think, application. Now I'm going to allow traffic from any service account that has a label on it, ratings reader. So if we go back up to a couple slides back, you would have a service account on the reviews pods, the reviews instances, and they each have their own unique, so they might have their own unique service account names, but you would attach a label to the service account you've added to reviews v2 and reviews v3. You'd attach a label to that it is a ratings reader or ratings consumer. So now you can do the same thing we talked about in the first instance, except now we're going to say that we don't care what the service account name is. We're just going to care if the service account has a label attached to it as ratings reader. So you can now start attaching capabilities to service accounts, and they can be shared across multiple service accounts, much like we talked before about saying many things might be LDAP clients, but you want to have a single policy that says LDAP servers will allow traffic from LDAP clients on 636. Here, there are many things that might need to read from the rating service. So instead of having a bunch of rules that says service account ratings v1, service account ratings v2, service account ratings v3, or v2 and v3, you now just attach to ratings v2 service account and ratings v3 service account the label ratings reader. So you now have a single policy to accomplish the same thing. One last topic I'd point out here, service accounts are an RBAC controlled resource, a role-based authentication controlled resource in Kubernetes. So unless you have, Kubernetes has given you, or within the Kubernetes RBAC environment, which is usually pinned and refers back to a corporate Active Directory system or LDAP or something along those lines, unless you have the permissions to manipulate that particular service account, you're not going to be allowed to do things like attach labels to it, etc. So this is something that is then traceable and loggable back in RBAC. And we looked at some of our previous, I forget how many weeks ago the compliance webinar was, Michael, but we did a whole discussion about how in Tigera's solution, we log all RBAC controlled events in Kubernetes. So if you're using Tigera's commercial solution, you would then see that the user Bob tried and was successful to attach a label to a given service account, the ratings reader, and you can see that Alice also attempted to do that, but she was denied because she doesn't have permissions to make modifications to that particular service account.
Yeah, I think that was about a month ago, and if people want to go back and look at that webinar, it is on our Bright Talk channel, so you can always go back and review that one. We have a question though. You were talking about service account, what it is. Is it just a meta label though in what we're discussing here?
So service accounts in Kubernetes are just an annotation. It's another type of label. It is unique in that it is RBAC controlled, i.e. you identify which users or groups of users are allowed to use a given service account, which is different than a label, standard Kubernetes label. Anyone with permissions to affect changes to a pod in a given namespace can attach labels. This is an instance where, if you think about it, the label itself is RBAC controlled. In Kubernetes, that's the extent of its use. It's basically an RBAC controlled label. One thing to keep in mind, you can only attach one service account to a given pod. So this is where attaching labels to service accounts makes them a little more usable, because you can only attach a single service account to a pod, much like a pod can only be in a single namespace. Istio then builds on that primitive of a service account, and if you turn on MPLS within Istio, then service accounts act as a stand-in identifier for the TLS certificate that will be generated for each pod. So you can then refer to that TLS certificate by referencing the service account that's been assigned to that particular pod. So in this case, we're using that service account really as a proxy for MTLS. If you haven't turned on MTLS, we still wouldn't allow the traffic, but it wouldn't be an MTLS test. It would just be a straight up deny. So, if you're concerned about security, etc., strongly recommend you use MTLS. It comes for free with Istio. You might as well use it. So any other questions at this point?
No, nothing yet.
Okay. Mike, is there any way we can hear snoring from our listeners to see if people are awake or not?
Well, you know something, I'm in marketing, and that was pretty clear to me. I think
okay. So now, pardon me. So now let's put these two things together. So we now have this, remember we talked earlier about pod selectors, and pod selectors are that L3, L4, what pods are labeled product page. So now we can say, if you're in app reviews, we're going to allow traffic if it's coming from a namespace with labels, with a label reviews reader, and from a pod that is labeled product page. So in this case, unless those two components come together, you're coming from an application, you're coming from a pod where the label app is product page, and you have a service account, which is RBAC controlled, reviews is with a label in the service account that's reviews reader, the traffic will not be allowed. So there's two interesting things here. One, you now have to have two pieces of data. This is sort of looking like two-factor authentication. You have to be coming from the right place, and you have to have the right credentials. But two, the enforcement of the pod selector component is going to happen at L3, L4 in the underlying host's kernel for this pod labeled app reviews. And the enforcement of the service account MPLS authentication is going to happen within app reviews pod in the Istio proxy. So we're now going to be doing enforcement at two different places. So even if one of those two enforcement points has been compromised, this policy will still be effective or mostly effective. And this is when we start talking about zero trust. We have to assume, if you remember me banging on this a month or two ago, you have to assume your infrastructure, your applications, every component of your infrastructure very well, or any component of your infrastructure very well might be compromised. If it's every component, well then the gig is up, but you have to assume that any given point may be hosting a compromise. So in this case, we're going to do enforcement based on 2 credentials in 2 different locations. And we'll show you what the architecture of this looks like in a minute. So let's keep.
So the question that says, is this policy just a Calico policy or is an Istio policy? So this is a Calico policy, but there's a benefit of using a Calico/Tigera policy, correct?
Correct. So this is not an Istio policy. This is something we've done here at Tigera. So this is a Calico and Tigera policy. It's driving behavior in some of the Istio components. There's a bit of a difference between Istio policy and Tigera policy. The Tigera policy, well, let's park that aside for a minute while we go over this, and we'll go into the architecture, and I'll show you how this is maybe a little different. So if we go to the next, is there any other question? Looks like there's maybe a third one.
It's probably for later in the end.
Okay, that's fine. Yep. So if we go to the third one, we can now, this is both an enforcement point and another piece of behavioral, in this case, a behavioral analysis. We can basically say, again, this is applied to anything labeled apps ratings, and we're still going to say we're only going to allow traffic from pods labeled app product page, and only from things that have a TLS certificate from a service account with a label ratings reader. So that's now being enforced in 2 places, like I said. But now we're going to say that traffic from those app product page ratings reader selected subset of traffic is only going to be able to do an HTTP GET, and we can only do that on a URL that starts with a path of reviews. So at this point now, you have to be coming from the right pod or set of pods. You have to have the right TLS certificates. And you have to be behaving correctly. You have to be just doing a GET. If you're trying to do a post to CGI bin or something along those lines, you're going to get bounced. So now we're not only doing enforcement in multiple places, we're actually looking at that L5 through 7 behavior, and specifically here that L7, that session behavior, to say, are you going for what you should be going for? So this allows, there's all sorts of interesting things here. For example, if you're making a database dip in this Redis database, and you're trying to get, customer record information when all you really should be able to get is their shipping address, you can bounce that. So, the shipping application shouldn't be able to read the order history of a customer. They should only be able to read, for example, their shipping address for this particular order. So you can now constrain application behavior while still enforcing it at a coarser level. If this thing's coming from a dev instance of your shipping application, it shouldn't be able to even connect to the production side databases. So we now have a single policy that enforces very, sort of network-centric rules all the way up to behavior. And this is all in one single policy statement. If you remember my comment earlier about having WAF rules not quite aligned with network policy rules and then trying to troubleshoot that again at 3 o'clock in the morning, you now have one artifact that describes the entire behavior I expect from one microservice talking to another microservice. What should be able to connect to? What TLS certificates it needs to bear to be able to make that connection, and even if it is an HTTP, gRPC, etc. session, what actual action it's trying to do and on what object. So how does this magic happen? If we go back to the first architecture slide, you'll remember, it would be Calico architecture slide. If we go back up, we're slowly scrolling back up. the architecture there, that slide. So Felix was writing those L3, L4 policies. Pods labeled Bob can talk to pods labeled Alice on 443. Those are being written to the host's underlying IP tables and IP sets infrastructure. Now, if we go further down and look at the architecture, now we've added just a few additional components. So in this model, Felix is still getting that policy from that Calico policy store, that key value store. But now that policy has statements that are L3, L4 based, and policies that are L5 through 7 based, i.e. service accounts, MTLS matching, HTTP verbs and targets, etc. So Felix then makes a decision for each of the rules within a given policy, or each of the components of a given policy. Is it going to write it into the underlying host's kernel, or is it going to write it into the Envoy proxy within a pod that is part of the Istio infrastructure? So in this case, that L3, L4 match of pods labeled product page can talk to pods labeled ratings, that would get put into the kernel net filter that basically says pods with this label are only allowed to receive traffic from pods with this other label. But the must, have a service account with a ratings reader TLS certificate and must only be able to do HTTP gets to a specific target. Those policies will be written into the Envoy proxy itself. So now we write into two different endpoints. If you'll notice, the Envoy proxy, we're writing into this locally. We're not storing this centrally, so Envoy doesn't have to go up and ask something. In Istio, for example, straight up Istio policy, you have to eventually go back and consult something called the mixer, which is sort of a centralized controller for all the Envoy nodes. You might have thousands and thousands or hundreds of thousands of pods, and that's scalable, but you're still making a request off board of the host. In our case, we proactively write the policies directly into the Envoy proxy, such that the Envoy proxy can make decisions locally when it sees traffic, and Felix takes care of updating those policies both in the network filters as well as Envoy of its hosted pods based on changes coming from Kubernetes and indirectly from Istio we receive through the Calico policy environment. So in that case, the workload then, when it sends traffic or when traffic is addressed to that pod for delivery to the workload, first of all, it has to get through the kernel network filters to make sure that that traffic's even allowed. And if it does, this is in case of a pod receiving traffic, the traffic will get delivered to the Envoy proxy first, which will then make a decision if all of the other characteristics on that service account, MTLS authentication, and HTTP gets in this case. The MTLS certification is driven by certificates which are granted by the Istio CA. The Istio certificate authority grants every pod running Istio a certificate, and that's where the service accounts come in. And Envoy, when we tell Envoy that we're interested in authenticating using service accounts a given transaction, then Felix will tell Envoy to make sure that mutual TLS is enabled for connections between these two types of workloads, and then standard checking against the Istio CA as certificate valid, etc., is done by Envoy. So we're driving that behavior. We go into a little bit more how this works. So Felix, what first happens is when a pod comes up that's using Envoy or using Istio, Envoy gets inserted as the Istio proxy. Envoy gets installed as a sidecar. The developer doesn't even have to do that. The developer can, or it can just be forced in as part of the deployment process. First thing that happens is Istio will assign that individual instance of a pod with a client certificate. And similarly, we will get a root certificate that validates the Istio CA is also installed in that pod. What happens then is if you're running Calico or Tigera's solution for L5 through 7, we install another sidecar that talks to Envoy that plugs into a filter mechanism that we developed along with the Envoy team. And that filter mechanism listens to Felix on the local host. So in this case, if policies come in or inventory changes, we now have more ratings, reader endpoints, etc. The local Felix will update that filter that's now resident in Envoy. That's transaction 3. Now what happens when traffic comes in? The arrow's going the wrong way on this slide, I just realized. So now, for example, if this workload needs to send traffic out, it will send this traffic, the traffic will get forced through the Envoy proxy. The Envoy proxy will do the TLS certificate check. We'll check to make sure that the activity is correct. And then if it is, we will allow the traffic by checking against the filter. And if it is, it will then send the traffic out of the pod, at which point it will have to go through the kernel network filters that we've installed to say, is this pod even allowed to open communications on this port to the destination pod? This is reversed for traffic coming back in. And that's traffic then, if it all matches, it goes off the host, goes across the network, and then goes through this in reverse on the receive side. So this is a little bit of a flow on how this works and how we're doing this enforcement. So if the pod gets compromised, for example, and somebody takes out the Envoy proxy on the pod, first of all, you're no longer going to necessarily have the right certificate. You may or may not, depending on how you did that. So the TLS, MTLS certification on the other side may not work. Even if you manage to keep that, you still would get blocked potentially by the network filters on both sides. If the network filters on the underlying host get compromised, you'll still have the MTLS authentication and the HTTP behavior checks within the Envoy proxy. So now you have to pop basically the certificate authority, the Envoy proxy on both pods, source and dest, and the underlying host kernel on both hosts supporting those two pods for source and dest in order for you to get full unvarnished access between these two pods. So you think about it, depending on how you count, 4, 5, or 6 different points have to be compromised in order to get this all to work. That becomes a very hard hill to climb for anyone other than the most determined aggressor, or the world's worst set of mistakes as far as configuration and configuration management.
All right. Well, this slide has opened up some questions, so we have several. So let's get to them. The question is there a practical tested limit to the amount of policies, pods possible? Does the number of policies impact performance or the responsiveness of the policy updates? And maybe are there some numbers to share about large production?
Sure. So the mechanism, the first thing to keep in mind here is the Calico policy store stores all the possible policies in a Kubernetes cluster, and it stores all the inventory, i.e. what pods exist with what labels, what service accounts, etc. That's on the same order of magnitude, if not less, of data than the rest of Kubernetes stores. Actually, it's a smaller subset than Kubernetes. So if we're using Kubernetes API server, this is a incremental load. It's not substantial. Felix on each host. There is no central controller in Calico's or Tigera's solution. Each host acts as its own local controller. So each Felix is then responsible for tracking if it has a new pod, etc., and looking back into the Calico policy store and saying, is there a new policy that I have to install? So let's say you have 10,000 policies in your infrastructure. This isn't like a legacy firewall where I have those 10,000 policies rendered everywhere. Felix selects the subset of those policies that affect for layer 3, layer 4 that are applicable for all of the pods it hosts. So in reality, we see maybe tens to hundreds. And those get installed in the Linux kernel via order one match mechanism. So it doesn't have a performance impact. There's literally no performance impact based on the number of policies or terms in a policy at layer 3 or layer 4. Similarly, Felix will only install the policies in a given Envoy filter that are relevant for that particular pod. So in this case, you might only have 3 or 4 policies that affect a given pod. If you're writing your policies correctly, and these are microservices, you're not going to be having 100 different policies. You're going to say this thing is providing the rating service, so therefore it's going to receive any traffic from things that are appropriately labeled ratings reader as a service account. So the policy is going to be maybe 4, maybe 5 within a given pod. So the Envoy filter will only have to search through a very small subset of policies in order to decide to allow the traffic or not. So this is basically taking the same principles of loosely coupled, highly distributed environments is the only way to make things work at scale. So, we test this infrastructure for L3, L4 out to Calico is the underlying network policy environment for all of the major Kubernetes, Kubernetes as a service offerings in public cloud. So for some of those, we've tested up to 3,000 nodes, which is sort of their max scaling at this point, in hundreds of thousands of containers with multiple policies per container. There is no performance impact. So because this is all very distributed, and we're borrowing the same concepts that Kubernetes uses to distribute its control plane, we expect to see similar scaling characteristics to Kubernetes in this regard. And we haven't really seen an issue where, other than just attempting to really seriously break things for our own amusement, we have not seen in practice any issues with scale.
Cool. So there's a question around MTLS. What are the recommended methods for obtaining a cert for polling, monitoring, dev with an endpoint from an outside cluster?
From an outside cluster. There's going to be a couple different ways of doing that. Normally what people will do, right now Istio does use the Istio CA. There's been people talking, there's work being done on being able to plug other CAs into this mechanism. What Istio actually uses is Spiffy or Acme to request a certificate from the Istio CA when a given pod comes up. And then usually what happens in an organization is you will delegate a CA cert from your corporate CA down to Istio, and the Istio would issue certs from within underneath that intermediate CA. So you could start using certificate chains to say I'm going to accept anything from the corporate CA or not. As far as we don't have a corporate CA, CA certs are pretty reasonably priced. Well, not reasonably. They're only mildly rapacious from the various certificate vendors out there. You can also use something like Let's Encrypt potentially as well to generate a CA that you could then use to potentially issue an intermediate CA to Istio. Similarly, you could just do a self-signed cert. That's usually what you'd see, for example, in dev or even in a closed environment. There's plenty of examples out there on the web as to how to create a self-signed certificate and to act as a root CA, and then generate intermediate CAs off of that, one of which you would probably grant to Istio.
Okay. It looks like, can the Tigera policy and the mixer policy and or telemetry be used simultaneously?
Sure. The mixer policy, I'm not quite sure which one's going to take precedence between the filter that's installed in Envoy or the Mixer policy. I'm not sure which one takes precedence. We'll have to go back and get an answer for that. But as far as getting the telemetry through Mixer, etc., yes, we don't interrupt any of the Envoy to Istio flows. We just add this local policy sidecar to the local Envoy. So everything will continue to work. Again, I'm just not sure if the Mixer-driven policies or the Tigera-derived local policies coming from Felix would take precedence. We'll have to get an answer for that. You can remind me after this. I'll get an answer for that.
Yep. So I'll read this one. Pardon me, maybe if we've already answered it. But how can these policies be used to secure communications with non-HTTP, gRPC services, Postgres? Now assume that a Postgres instance is a legacy app. Did we kind of cover that, or
we sort of
out of the K8s cluster?
We sort of did. So the way we would be doing, if that's in the K8s cluster or not, you would then revert back to just L3, L4 policies, right? So you would use L3, L4 policies to say things labeled DB server, cust DB server will allow traffic in from things labeled cust DB clients, and the reverse policy, cust DB clients can send traffic to things labeled cust DB server on the Postgres port. And then using Tigera's host endpoint mechanism, which again we talked about 2 weeks ago, and go back and look at the hybrid use case environment, we can attach labels and even install Calico if you wish on non-Kubernetes endpoints. So if you have a legacy database server in a VM or even a bare metal host or on a, whatever it might be, you can install an Oracle rack. You can install Calico on that. You can attach labels to that non-Kubernetes workload, and it will become part of the Kubernetes, the Calico environment from a policy standpoint. So it doesn't matter if it's a Kubernetes pod or a bare metal host or a VM. So long as it's labeled, the policies will still fire for layer 3, layer 4. Now, Envoy does support other protocols other than HTTP and gRPC. So there are constantly people adding other session mechanisms to Envoy. Right now, our plugin drives HTTP, gRPC is next, but if there's substantial demand from the customer base for enabling potentially filters for other things like Postgres, etc., or Redis, we'd love to hear that as we do product development going forward. If there are other session or protocols that people would be interested in hearing.
Yeah. So that kind of sounds like it answers the big question is people have around like, well, why not just use Istio only for security? What else do I need? And the answer really is that a solution like Tigera Calico not only gives you a single place to manage both layers, all 3, 4, and through the app, but also then it gives you that ability to go into non-K8s environments and bare metal and VM and apply policy across all of those.
Correct. It's that. We can also federate this across multiple clusters, which is not something you're going to get in Istio today. So you can federate this policy. Again, looking at the webinar from 2 weeks ago, we started talking about federation a little bit. The policy federation will federate this L5 through 7 as well across infrastructure, with some caveats right now, but we're working on those, and it's too deep in detail to go in here.
Yep.
The other thing to keep in mind is what I discussed earlier is we do enforcement also outside of the pod. All Istio enforcement happens within the pod. So if the pod becomes compromised, a number of Istio filters can be removed. So we have this belt and braces approach where even if the pod becomes thoroughly compromised, the network policy layer, things labeled Bob can only talk to things labeled Alice on 443, would still be in place in the underlying host. So it would prevent the pod from being able to talk to things that aren't labeled Alice, even though the Istio policy, which you were using to enforce that, has now been removed.
Mm-hmm. And what would happen if Felix crashes or otherwise goes down?
Felix never crashes. We don't write any buggy software here. You should know that answer. In reality, Felix is not in the data path here, right? Felix is writing updates as they come from Kubernetes or other inputs into the Calico policy store. So new pods come up, policies get changed, etc. That's when Felix fires and updates potentially filters in Envoy or in the kernel. It is not referred to in real time in packet, on a packet or session flow basis. So it writes the rules into Envoy and then in the kernel, and then they act on those rules. So if Felix goes away on a host, the policies that existed at the point Felix went down will continue to operate. So the traffic will still flow, existing flows will still flow, new flows that meet policy will still be allowed, flows that don't meet policy won't be allowed. If policy changes in the interim, those policies will not be updated on the host where Felix is down. However, Felix is very lightweight. Felix doesn't have, frankly, a lot of state. So if Felix crashes, Kubernetes will restore Felix usually within a second or two, because Kubernetes we deploy as a deployment, as a daemon set. So Kubernetes will note that Felix goes down. It will restart Felix. First thing Felix will do when it comes up is it will look at the current state of its filters on the host and in its pods, compare that to what it should be doing based in the policy store, the Calico policy store, and then make changes. So traffic won't be interrupted, and as soon as Felix comes back, it's not like we're going to drop all traffic and relearn everything. We're just going to make delta changes to those policies based on updates that have happened while Felix was getting rebooted.
This is more of an Istio question, it looks like, but what will it take to get stateful, headless services to work on an Istio mesh?
That one, stateless headless services, that's probably going to take more time to answer than we have here.
Okay.
So,
yeah,
I don't have a good answer in the time remaining for you, but maybe this speaks to we should have a more general Istio overview at some point, Michael.
Okay. All right, I think that's we have let's keep moving on. So
okay,
continue.
I think anticipated benefits. I think we already sort of covered all of the anticipated benefits. Labels are significantly more flexible than service names. Labels can be attached to multiple service names. They can refer to many different things. They can be scoped across namespaces. The other thing that we've discussed in Calico and Tigera, especially in the Tigera commercial product, is multi-tier hierarchical policies. The security team can have, say, compliance policies like PCI policies or geographical policies, and then the development teams can have very fine-grained policies that reflect the application graph. All of those tiers, we discussed this earlier as well in the previous webinar, all those tiers also work for this L5 through 7 policy as well as L3, L4. So you can have PCI policies that affect layer 5 through 7 as well as layer 3, layer 4. And I think everything else we've already discussed.
Yeah.
So,
well, actually, we've come to the top of the hour. We took a whole hour. There are some questions we didn't get to. Those will be noted, and we will get back to you with the answers to those questions. One last note for everybody. We have some upcoming events that I think are relevant. So the next webinar we have coming up in about 2 weeks is about leveraging Kubernetes services in DNS. And also, if you are going to KubeCon in Seattle next week, please stop by the Tigera booth. You can see where all the information is. We are a platinum sponsor for KubeCon, and you can see where our booth number is and come by and say, hey, and get a demonstration and talk more in depth about any of the questions you might have had.
And I'd love to ask from anyone here who's going to KubeCon, please come and find me at the booth. I'd love to get feedback, good or ill, about the webinar series and what I could be doing better that would make things more useful.
Yep. Okay. Well, thank you everyone for attending. That's the end of our webinar. Like I said before, it was made available right after we close it on BrightTalk, and we will be pushing out copies of the PowerPoint slides if you prefer them. And we thank you for attending, and we'll see you next time.